right, for number 24, it says evaluate each determinant. So for the determinant, what you do, and notice how these bars, that actually does mean the determinant of a matrix, as opposed to these right here, which indicates a matrix. So to find the determinant of a 2 by 2, you multiply this times this, so 2 times 3, 2 times 3, and you subtract, so A times D minus B times C, so negative 4 times a negative 4. So you get 6 minus 16, so that's negative 10. The determinant is negative 10. Over here, we've got 1 times 3 minus, so minus negative 1 times negative 5, that is 5, so that is negative 2. So the determinant is negative 2. Find the inverse of each matrix. So for the inverse, what you're going to do is you're going to figure out the determinant, figure out the adjugate, multiply, and then that's your inverse. The multiplicative inverse anyway. When they say inverse, they mean multiplicative. So the determinant is negative 32 minus 8, which is a negative 40, because negative 8 times negative 1 is positive 8. Okay. And then so I've got negative 1 over 40 times the adjugate, and the adjugate is where you switch these two, negative 8, positive 4, and then you just change the sign of these. And so that would be negative 140 times negative 8 is a positive 1/5. That is a negative 1/5. This is a negative 1/40th, and this is a negative 1/10. And that is the multiplicative inverse, and that's all you're having to do. You're not having to solve anything. There's nothing to solve. I do want to show you just real quick. In your calculator, if I asked you to find the inverse, all you'd have to do is go alpha zoom. It's a 2 by 2. And I'm going to enter in 4, negative 8, negative 1, negative 8. And then right here, I'm going to put, so this button right here, above, below matrix, I guess. The button the matrix is above is negative 1. So that means the inverse. Press enter, and it will give it to you, and you can do math, enter, and it'll give it to you as a fraction. So 1/5, negative 1/5, negative 1/40th, and negative 1/10. And there you go. So for 27, we've got the determinant. So 1 over, that's going to be 90 minus 54. 90 minus 54 would be 36. Yeah. So 1 over 36 times the 90 minus 54. And then we got the adjugate. So we switch negative 10 and negative 9. We change the sign, negative 6, negative 9. That's all the negatives. So the inverse would be 10 and 36, 5 and 18. So negative 5/18, negative 1/6, negative 1/4, and negative 1/4. And that should be the inverse. Let's check it. So again, I'm going to do alpha zoom. It's a 2 by 2. We're going to find the inverse of negative 9, 6, 9, negative 10. The inverse, and math, enter. Negative 5/18, negative 1/6, negative 1/4, and negative 1/4. We're good. Okay. Number 28. It says write the augmented matrix for each system of linear equations and solve the system using the multiplicative inverse by hand and then solving using the calculator inverse and REF. So I'm going to do all three. So first, I'm going to write this as an equation, a matrix equation anyway. 5, 1, negative 5, negative 3 times xy equals negative 9, 17. And that is the matrix equation. Now what we need to do is find the answer, right? So if I were to ask you to solve 2x equals 7, you would multiply both sides by 1/2. But you wouldn't spend your time showing me that 1/2 times 2 simplifies down to 1. You would figure out what this is, right? So, same thing here. I'm going to figure out what the multiplicative inverse is over here, but I'm not going to actually multiply it out. I'm just going to do this part. So I'm going to model for you exactly what I would expect for you to do. Alright. So, we're going to find the multiplicative inverse. We're going to do 1 over the determinant. So the determinant is going to be negative 15 minus a negative 5, so plus 5, that means it's a negative 10. So a negative 1/10 times the adjugate, so the adjugate, we're going to switch the negative 3 and the 5, and change the sign of 1 and negative 5, so negative 1, positive 5. Okay, so the multiplicative inverse is 3/10, 1/10, negative 1/2, and negative 1/2. That's what we're going to multiply. So technically what we would do is we would multiply that right here and right here. It has to be in the same exact order. The multiplicative inverse times the matrix, the multiplicative inverse times the matrix. So in actuality, the only thing I need to see from you, or the, you know, as far as like the solving process goes, is multiplying the multiplicative inverse times the right hand side of the equation, which is negative 9/17. So remember that we multiply matrices by doing row by column. So this is a 2 by 2 by a 2 by 1, which means my answer is going to be a 2 by 1. So it's going to look like 2 rows, 1 column. And the only reason I did them wide is because I'm going to show you the steps that I'm going to do to figure out my answer. So I've got row by column. 3/10 times negative 9 is negative 27/10. And 1/10 times negative 9 is negative 9/10. Oh my gosh, I don't know why I just did that. Row by column, that's ridiculous. 3/10 times negative 9, and then 17 times 1/10. That was bad. Super bad. Okay, row by column. This plus this. Okay, and that actually adds up to negative 10/10, and that is negative 1. And then row by column. So row by column. Negative 1/2 times negative 9 is a positive 9/2. And then minus 17/2. 9 minus 17 is, let's see, 17 minus 9 is 8. Oh my gosh, it took forever. Negative 8/2, so that's a negative 4. Oop, I should have wrote it like this. So that's the matrix, negative 1, negative 4. The answer is the coordinate point negative 1, negative 4. X and then Y. Okay? Because in actuality what happens is you're just left with the matrix X, Y, because these simplify down to the multiplicative identity, 1, 0, 0, 1. X, Y equals the answer. So the equation will simplify down to that. But that means the coordinate point negative 1, negative 4. Okay, now it does say to do it by calculator, so I'm going to show you this right quick. All right. So we're going to multiply. Okay, sure. Here. There you go. Okay, so we're going to multiply the, well, actually, okay, I could do this. I could type this in, but I'm going to go ahead and just, like, have the calculator find the inverse. Because remember, we found the multiplicative inverse and multiply times that, right? So, alpha zoom, 2 by 2. I'm going to type in the original. 5, 1, negative 5, negative 3. Oop. And then we're going to, the inverse of that. So the inverse times alpha zoom, this is, they were going to multiply it by this matrix, which is a 2 by 1. Okay, so negative 9, whoop, and 17. And I get negative 1, negative 4, and that's my answer. Now that was using multiplicative inverse, and again, you could have found the determinant. You could have said second matrix math, determinant of the matrix. I'm going to go up here and grab this and just delete some stuff. Okay, so if I asked you to find the determinant of the matrix, you could do it in the calculator, negative 1 or negative 10. I don't know if it does the adjugate in there. I think you just find the, yeah, no, you're good. Okay. So, one more thing though, I could ask you to find it using RREF, and in fact, I do want you to know how to do that. So, for row reduced echelon form, all you do is you go second matrix, you go over to math, and then you go up to RREF, or down, but up is a little bit faster, so press enter. And then alpha zoom, and then what you do is you type in not the 2x2, but the 2x3, the entire thing, the whole equation as a matrix, in the augmented matrix. We just don't have the bar on there. So 5, 1, negative 9, negative 5, negative 3, and 17. Type it in and you get your answer. 1, 0, negative 1, 0, 1, negative 4. So here's the equal sign, right? 1x plus 0y equals negative 1, so x equals negative 1. 0x plus 1y equals negative 4, so y equals negative 4. And there you go. Okay. Let's do it again. Number 29. I'm going to write it as an equation. So negative 3, 4, negative 5, negative 2, x, y, 19 and 23. Okay. I'm going to find the multiplicative inverse, and that is what we're going to multiply by 1923. So 1 over the determinant, so that's going to be the determinant, if we let this be matrix A, then the determinant of A is 3 times negative 2, which is positive 6, minus 4 times negative 5, which is negative 20, so plus 20, that is 26. So 1 over 26 times the adjugate, we flip those, negative 2 and negative 3, or swap them, and then change the sign. And then distribute. So I've got negative 1/13, terrible 3. Negative 2/13, 5/26, and negative 3/26. And that is what we multiply on both sides of the equation, but we only really need this side. So we're going to say negative 1/13, negative 2/13, 5/26, and negative 3/26 times 1923. And we multiply row by column. Again, it's going to be a 2 by 1. Okay, so row by column. Negative 1/13 times 19 is negative 19/13. And then negative 2/13 times 23 is negative 46/13. So 46 plus 19 is negative 65/13. Let's see. Negative 65/13. Is that negative 5, 5, 50, and yeah, okay, so that's negative 5. And then we've got row by column. So 5/26 times 19. Ooh, these are big numbers. So 50 plus 45, so that would be 195. No. I don't know why I just did that. 95 over 26, and then plus negative 3/26 times 23, so that's negative 69/26. That's 60 and then 9, yeah, okay. So then 45 minus 69 would be 69 minus 45. Is that going to simplify? Oh, 95, not 45. Okay. 95 minus 70 would be 25, so 26. So 26, which is 1. Good. Final answer is the coordinate point, negative 5, 1. And you couldn't see that. Okay, so practice it by hand one more time. I'm going to multiply the inverse of the multiplicative inverse of that times that. So alpha zoom, 2 by 2, negative 3, 4, negative 5, negative 2, inverse times alpha zoom, a 2 by 1, 19, 23, and then negative 5, 1. Okay, good. reduce echelon form, so second matrix over to math, up to RREF, and then alpha zoom, 2 by 3, and -3, 4, 19, -5, -2, 23, enter, and then there's my answer, -5, 1 again. All right, one more. So we've got 4, 3, 3, -1, x, y, -23, -1. And there's my equation. All right. We're going to figure out the multiplicative inverse. We need to find the determinant. So -4 minus 9. -4 minus 9. That's a -13. So I've got -1/13 times the adjugate. So that's -1, -3, -3, and +4. So my multiplicative inverse is 1/13, 3/13, 3/13, and -4/13. And that's what we multiply both sides by. And so here we go. 1/13, 3/13, 3/13, -4/13 times -23 and -1. Row by column. So this is going to be, okay, 1/13 times -23 is -23/13, and then minus 3/13. 3/13 is -1, so negative. Okay, and that is going to add up to -26/13, and -26/13 is -2. And then row by column, so 3/13 times -23, that would be -69/13, and then plus 4/13, so that's -65/13, and that is a -5. So my final answer is -2, -5 as the coordinate point. All right. I'm not going to show that in the calculator. I'm going to show these in the calculator though. It says write the augmented matrix for each system of linear equations. So the augmented matrix is the one where the whole equation goes in there. And it is x, y, and z, even though you can't see it in the first one. So we're going to have x, y, z, and then equal sign, and then the constant. All right, so in the first equation, we've got a 3x, a -2y, no z. Augmented matrix, you put the bar for the equal sign, and then the 12. You've got -3, -3, 1, -14, and then we've got 5, -1, 4, and 12. So if they were not in the correct order, then you got to make sure you put them in the right order. And then it says use solve using RAF in the calculator. So all we do is go second matrix, so that's above the button that has x to the -1, so second matrix. Go over to math and go up or down to RREF. And then this is a 3-row, so 3 rows by 4 column. So alpha zoom, 3 by 4. Okay, and then we just start typing them in. Now guys, a lot of people, you guys you press the down arrow to go down, you go left, you go right. Always go right, and it'll always put you in the next one, okay? So let me zoom out a little bit. So, 3, -2, 0, 12. Press right again, and you'll jump down to the next row. -3, -3, 1, -14. 5, -1, 4, and 12. Press enter, and you get this matrix when you got 1, 0, 0, 4, 0, 1, 0, 0, 0, 0, 1, -2. That means x plus 0y plus 0z equals 4, so x equals 4. y equals 0 and z equals -2. So that actually means the answer is the coordinate point x, 0, -2, x, y, and z. And so what you're actually doing, if you've got your x and your y and your z axis, that means you are going to the right 4, you're going up none, and then you're going backwards 2. So you're actually going out in that direction. But it's flat on the xz plane because you don't go up any y. Okay, and then let's talk about 32. So let's write the augmented matrix. -4 is x, y, z. We don't have a y, so 0, and then 4, and then 0. -4, 5, 1, and 4. -1, 3, -2, and 0. And then we're going to solve right quick. So second matrix, over to math, up to RREF. Alpha zoom, whoop, 3 by 4, and just enter it in. So -4, 0, 4, 0, -4, 5, 1, 4, -1, 3, -2, and 0. And we get 2, 2, 2, which is interesting. Okay, so we get the coordinate point 2, 2, 2, which actually means on the XYZ plane, we are going to the right 2, we're going up 2, and then we're going out 2. So it actually goes to the right 2, up 2, and then out 2. So I'll have to show you. Let's see. Oh, how did I draw those? Not that you can even see. You come forward 2, and then you go up 2. So that would be in line with oh, fiddlesticks. How did we do that? Oh yeah, oh yeah, oh yeah, oh yeah. And then you create that box, and so technically you're going out 2, up 2, and then forward 2. So out 2, up 2, and then in towards me. Although it's kind of awkward to see. I'm going to draw a little bit different angle. So 1, 2, 1, 2, 1, 2. So I don't know why I drew those so far apart, but you go out 2, up 2, and then into. So it's easiest to just draw like the box created by this, and so we go parallel. Again, my line. Where's this back line? So you can see that the coordinate point would actually be out in space over here. Okay. Anyway, I'm actually going to show you how to solve these by hand when we come back, and that'll be fun. But we don't have to graph 3D by hand. Okay, we have the last questions about matrices. What are the dimensions of matrix A? So matrix A is row by column, 3 rows, 4 columns. So 3 by 4. What is the entry located at A24? So that means matrix A, row 2, column 4, and that would be 5. What is the address of -3? So that would be A, row 2, column 3. So A sub 2, 3. In matrix B, this is what are the dimensions of matrix B. It is row by column, so it's 1 row and then 4 columns. So 1 by 4. B11, row 1, column 1 is 5, and then 1 is B row 1, column 4. So B sub 1, 4. And then we have all these matrix operations that we're supposed to do. So for number 35, we're supposed to add C and F. Well, C, let's go ahead and write our dimensions down. C is a 3 by 3. D is a 2 by 2. E is a 3 by 2. F is a 3 by 3. G is a 1 by 4. H is a 4 by 2. I is a 2 by 2. And J is a 2 by, oh, just kidding, 1 by 2. 1 row, 2 column. Okay. The only way that you can add matrices is if they have the exact same dimensions. This is a 3 by 3 and that's a 3 by 3, so we're good. So I'm actually going to write them out so you can see it when I'm adding, but you wouldn't necessarily have to do that. 5, negative 6, 3/5. 0, negative 4, 8. 10/3, negative 11, and 12. We're adding that to F, which is 2, negative 4, 0, 5 halves, 11, negative 2, 5, 0, and negative 10. We're going to do this without a calculator because we can. And so, if you add a 3 by 3 and a 3 by 3, you get a 3 by 3. So, row, we're going to add these. 5 plus 2 is 7. Negative 6 plus negative 4 is negative 10. 3/5 plus 0 is 3/5. 5 halves, so that's frustrating. I'm adding zeros and fractions. That's boring. 5 halves, 7, 6. 10/3 plus 5. So if I have to add 10/3 plus 5, 5 is 15/3, so that's 25/3. So 25/3, negative 11, and 2. Well, that negative 11 is a little bit over, but negative 11. And there's my answer. So just C plus F. On 36, 2D minus 4I. So that's 2 times the matrix D. So 2D is going to be 18, negative 6, 0, and 4, minus 4I. So 4 times the matrix I, which is going to be 0. 4 times a half is 2, 4, and negative 28. And then if we subtract, a 2 by 2 minus a 2 by 2 is another 2 by 2. 18 minus 0 is 18. Negative 6 minus 2 is negative 8. 0 minus 4 is negative 4. And 4 minus a negative 28 is a positive 32. And that is your answer. Okay. On negative 2FE. Okay. So what we're going to do is we're going to multiply. You could actually multiply negative 2 times F. You could multiply negative 2 times E. You just don't multiply it times both of them. Or don't distribute it anyway. I'm actually going to leave the negative 2 to the end just because I like to keep the number smaller inside the matrices. So negative 2 times F, which is it should be open. Hello. It's okay. Give me a minute, okay? Alright, so F is 2, negative 4, and 0. 5 halves, 11, and negative 2. 5, 0, and negative 10. And we're multiplying that times E, which is 5, 2, 0, negative 4, 1, 6. And let's make sure that we can do that. We're multiplying a 3 by 3 by a 3 by 2. We can do that because the inner dimensions match, and then the answer would be a 3 by 2. So I know my answer is going to be 3 rows and 2 columns. Okay. So let's fill it in as we go. Row by column. So I've got row by column. Negative, or 2 times 5 is 10. Negative 4 plus 0, or times 0 is 0. And then we're adding all these, and then 0 plus 1 is 0. So the first answer is going to be 10. First row, first column. If I multiply first row to, oh, just kidding, no. And then we're going to have times negative 2. And then first row times second column is going to be 2 times 2, which is 4, plus negative 4 times negative 4, which is 16, plus 0 times 6, which is 0. So that's plus 20. I don't even know why I still have it over. I could just have it right here. Okay. So that's 20. Then I've got second row times first column. 5 halves times 5 is 25 halves. 11 times 0 is 11. 0. And then negative 2 times 1 is negative 2. So 2 is 4 halves. So 4 halves, negative 4 halves, plus 25 halves is 21 halves. And then second row times second column. 5 halves times 2 is 5, minus 44, minus 12. So that is negative 56 plus 5, so negative 51. And then row by column. Third row, first column, 25 plus 0 minus 10, that's 15. And third row, second column, 10 plus 0 minus 60, so that's negative 50. So then our final answer is going to be 20, negative 40, negative 21, 102, negative 30, and 100. And let's just make sure on that. Okay. Here we go. Negative 2 times alpha zoom, we're going to do a 3 by 3. So I've got 2, negative 4, 0, 5 halves, 11, negative 2, 5, 0, negative 10, times alpha zoom, this is a 3 by 2. And then we've got 5, 2, 0, negative 4, 1, 6, press enter. Okay, so, negative, oh crap, I'm missing negative. Negative 20, negative 40, negative 21, 102, negative 30, 100. Okay, well, I missed a negative, so I guess I'm fired. Alright, and then I'll finish the last bit on the last video.